Dear student, myself Dr. Surekha B. Jaiswal, Head Department of Physics, Moreshwar College, Bhokardan, District, Jalna. Today we will see mechanics, properties of matter and sound. Semester first, course code number Phy101. Now, contents are introduction, compound pendulum expression of time period, interchangeability of center of suspension and oscillation, center of oscillation, interchangeability of center of suspension and oscillations. Now, introduction. Mechanics is a branch of the physical concerned with the state of rest or motion of bodies that are subjected to the action of forces. The study of mechanics involves many subject areas. However, initial study is usually split into two areas, static and dynamic. Static is concerned with bodies that are either at rest or move with a constant speed in fixed direction. Dynamics deals with the accelerated motion of bodies. Static can be considered as a special case of dynamics where the acceleration is zero. Mechanics deals with the dynamic of particles, rigid bodies, continuous media, fluid, plasma and solid mechanics, and field theories such as electromagnetism, gravity, etc. This theory plays a crucial role in quantum mechanics, control theory and other areas of physics, engineering and even chemistry and biology. Clearly, mechanics is a large subject that plays a fundamental role in science. Mechanics also played a key part in the development of mathematics. Now, compound pendulum expression of time period. Now, compound pendulum is defined as a rigid body which is capable of oscillating freely about a horizontal axis passing through it. Its vibrations are also simple harmonic and its time period is given by the relation T equal to 2 pi under root of I upon mgl, where I is its moment of inertia about the axis of suspension, m equal to mass of rigid body and l be the length of pendulum. Now, see expression of time period. Now, for this, let us consider S be the point of suspension of the body. See in figure, that is a compound pendulum. Here, S is the point of suspension which passes a horizontal axis perpendicular to the plane about which the body oscillates. Its center of gravity lies vertically below S. Now see here, that is the point of suspension and the G is here center of gravity, that is denoted by capital letter G. See, now that is lies vertically below S in its normal position of rest as shown in figure. Let the body be displaced through an angle theta so that its center of gravity becomes G dash. See, this rigid body shown in this figure like this rigid body, that is a compound pendulum, is displaced through an angle theta, see in figure. Then its center of gravity changes to G dash as shown in figure. Now, moment of restoring couple or torque equal to minus mgl sin theta. Torque equal to minus mgl sin theta. If the angular acceleration produced in the body by this couple is d square theta by dt square, angular acceleration for this rigid body is given here, d square theta by dt square. Now, where I is moment of inertia of the body about an axis through the point of suspension S and perpendicular to the plane, so that here I into d square theta by dt square equal to minus mgl sin theta. If theta is very small, then sin theta becomes theta. So, using this relation, I into d square theta by dt square equal to minus mgl theta. I into d square theta by dt square plus mgl theta equal to 0. So, d square theta upon dt square plus mgl theta upon I equal to 0. This equation is similar to the differential equation of SHM. Hence, its time period is given by t equal to 2 pi upon omega. So, comparing equation 1 with equation of differential equation of SHM, we get d square theta upon dt square plus omega square theta equal to 0. So, omega square equal to, comparing this equation 1 with this equation of SHM, omega square equal to mgl upon I. So, omega equal to under root of mgl upon I. So, t equal to 2 pi into under root of I upon mgl. We know that the principle of parallel axis is given by I equal to I0 plus ml square. So, using this relation, if I0 be the moment of inertia of the body about an axis passing through G, its center of gravity, and parallel to the axis of suspension through S. So, I0 equal to mk square, where k be the radius of gyration of the body about the axis through G. So, I equal to mk square plus ml square. Now, putting this value of I in equation 2, we get t equal to 2 pi, I equal to what? mk square plus ml square. So, t equal to 2 pi into under root of mk square plus ml square upon mgl. Now, t equal to 2 pi k square plus l square upon gl. So, therefore, t equal to 2 pi into under root of k square upon l plus l upon g after simplification. Now, that is, the period of vibration is the same as that of simple pendulum of length k square upon l plus l, which is length of an equivalent pendulum. Now, interchangeability of center of suspension and oscillation for compound pendulum. Now, center of oscillation. A point O, see in figure, that point. A point O on the other side of G at a distance k square upon l. See, that point G is the center of gravity of this compound pendulum, and O is the here point of oscillation having the distance from this center of gravity G, that is a k square upon l, and a horizontal axis through it parallel to the axis of suspension is known as the axis of oscillation of the pendulum. O is known as center of oscillation. Thus, GO equal to K square upon L, see in figure. Now from figure, now putting it equal to L dash to, so we have SO equal to L plus L dash. So SO equal to L plus K square upon L, and therefore T equal to 2 pi into under root of L plus K square upon L upon G is equal to 2 pi into under root of L upon G. Thus the point of oscillation O lies at distance L from the point of suspension S, or the distance between the two gives the length of equivalent simple pendulum. Now interchangeability of center of suspension and oscillation. If the pendulum be suspended about the axis of oscillation through O as shown in figure B, see in figure B. In this figure, see in figure, time period of vibration will be given by T equal to 2 pi into under root of K square plus L dash square upon G into L dash. Since K square upon L equal to L dash, therefore K square equal to L into L dash, so that the expression for the time period T is becomes T equal to 2 pi into under root of, putting the value of K square here, under root of L into L dash plus L dash square upon G into L dash. So after simplification we get T equal to 2 pi under root of L plus L dash upon G, and therefore T equal to 2 pi into under root of L plus K square upon L in upon G, which is the same as that of about the axis of suspension through S. Thus the center of suspension and oscillations are interchangeable. Thank you.